Welcome back to The Explainer. Okay, let's jump right in, because today we're looking at something that honestly feels straight out of a sci-fi blockbuster, but it's literally happening on our servers right now. We're talking about the intelligence explosion, that exact moment when artificial intelligence stops just being a tool that we build and actually starts building itself. So, are we looking at a runaway singularity here, or is there a hard ceiling we're about to slam into? Well, we're going to unpack the reality, the hype, and the actual physical limits of machines building better machines.
Okay, let's dive into this. It's arguably the most thrilling and, let's be honest, kind of terrifying question in all of technology right now. Can one AI create a better AI tool? Because if the answer is yes, then the rules of human progress completely change forever. Think about it. Every new version of an AI wouldn't just be smarter, it would actually take less time to build the next one. We wouldn't just be dealing with smart algorithms anymore, we'd be dealing with an acceleration of improvement itself. To really get a grip on this, we've got to trace the 60-year history of this exact idea. Way back in 1965, British mathematician I.J. Good first proposed the intelligence explosion. Decades later, in 1993, Werner Vinge gave it a date and a name you've probably heard, the singularity. Fast forward to 2008, and Eliezer Yudkowsky makes this brilliant analogy. He compared AI self-improvement to the very first self-replicating molecule on Earth. For billions of years, literally zero progress. And then, one molecule copied itself with a slight error. It didn't need to be infinitely smart. It just needed to be the only thing moving fast, while everything else stood perfectly still. And by 2014, philosopher Nick Bostrom formalized the ultimate question. At what exact point does AI contribute more to its own improvement than the humans building it? Which brings us back to this profound statement from I.J. Good from 1965. He said an ultra-intelligent machine would be, quote, the last invention that man need ever make. It's an awe-inspiring and, yeah, slightly intimidating thought, isn't it? If a machine is even fractionally better than us at designing machines, it designs a third one even better and a fourth one faster. It's a literal chain reaction. And the crazy thing? Today, we are absolutely seeing the very first sparks of that reaction. And this brilliantly illustrates how modern machine learning isn't just waiting around for the future. It's already using AI to build AI. We're seeing massive models acting as teachers to distill their knowledge down into hyper-efficient student models. We have automated architecture search. That's where an AI tests thousands of mathematical structures to find the best brain design, meaning many of our best models right now weren't even architected by humans. AI is generating its own synthetic training data, essentially writing its own textbooks. And with RLIIF, AIs are actually judging and guiding the learning of other AIs. Over at Google DeepMind, an AI called AlphaEvolve actually sped up the training of the very model that powers it. It literally made the thing that makes it better at making itself. Mind-blowing, right? To show you exactly how fast this feedback loop is tightening, just think about this number, 7. Researchers have measured how long AI agents can work entirely autonomously on real-world tasks, and that duration has been doubling every 7 months. Back in late 2025, that window was about 4.5 hours. If you extrapolate that trend line out, we're looking at AI systems handling month-long autonomous projects within the next few years. The gap toward a fully closed, completely autonomous loop is shrinking fast. Which brings us right up to February 2026. OpenAI released GPT-5.3 Codex, and they explicitly called it the first model instrumental in creating itself. Meanwhile, over at Anthropic, they're seeing AI write a significant portion of its own underlying code. So the hype? It's incredibly real. The systems we use today are out there actively patching, optimizing, and rewriting the code for the systems of tomorrow. But before we pop the champagne and declare the singularity is officially here, we need a bit of a cold shower. I want to pivot for a second and ask a really provocative question. If the most visionary, well-funded human team in history completely failed to maintain a loop of tools improving other tools, why are we so certain an AI can pull it off? Let's look back at history for a second. In 1962, a brilliant pioneer named Douglas Engelbart, this is the guy who invented the computer mouse, hypertext, and basically gave the world the mother of all demos in 1968, he tried to do exactly this. He built a team to use computers to build better tools, to build even better tools. He had the funding, he had the genius, he had a massive head start, and it completely fizzled out. The whole team just fell apart. Why? Because human organizational chaos often entirely defeats pure intellect. Real world-changing progress doesn't usually come from a single closed loop of genius. It comes from thousands of smaller, distributed insights spread across a massive ecosystem. This brings us to what researchers call the bootstrap problem. We have to really understand the difference between narrow optimization and general intelligence here. Think of a brilliant 8th grade math student. They can solve very specific, highly complex equations flawlessly. But they can't exactly sit down and design a university physics curriculum from scratch, right? That requires the PhD physicist, a broad, creative generalist. Right now, AI is that specialized student. It can optimize a network to be 20% faster, sure, but it completely lacks the creative, general intelligence needed to invent a massive paradigm shift, like when human researchers invented the transformer architecture. And, we have hard data proving that just scaling things up doesn't equal general genius. AI researcher Francois Chalet built the ARC test specifically to measure if an AI can actually solve reasoning problems it has never seen before. AI companies threw 50,000 times more computing power at this test over 5 years. The result? They completely failed to solve it. In fact, on the harder versions, the bigger models actually performed worse. Intelligence isn't just a volume knob you can crank up. Getting bigger absolutely does not automatically mean getting smarter. Beyond those cognitive limits, there are some hard physical ceilings approaching fast. First up, data exhaustion. We are currently on track to run out of high-quality, human-generated training text by 2028. And if AI just trains on synthetic data generated by other AIs, we risk what's called model collapse, where the system actually gets blander and more generic over time. Then there's the uncompromising floor of physics. You simply cannot process information without generating heat. Unless we plan on moving every server farm to Antarctica, the universe has set a hard speed limit that we literally cannot engineer our way out of. So, the crucial point is, the real bottleneck here is staggering. Advanced AI models use 40 to 100 times more electricity per query than a standard internet search. Global data center power consumption is set to double by 2030. Even if the software could theoretically self-improve forever, the global power grid and the laws of thermodynamics are going to force a speed limit on this explosion. And then there's the economic ceiling. Consider this research from Stanford economists regarding Moore's law, the steady doubling of computer chip performance. To maintain that exact same rate of progress today compared to the 1970s, it actually takes 18 times as many researchers. The conclusion across almost all scientific fields right now is that ideas are just getting harder to find. The easy wins are taken. What this means for the AI hype cycle is that a self-improvement loop might not go supernova. It will likely just flatten out as the problems get exponentially harder to solve. Let's move to and see how this builds, because human ingenuity doesn't just stop at a roadblock. When just building bigger models stopped working, labs tried a totally different path, letting the AI think longer. OpenAI's O3 model took that unsolvable ARC test we talked about and jumped from a 32% to an 87% success rate. It had the exact same training. It wasn't a larger model. It just spent more time reasoning through the problem before spitting out an answer. When the raw scaling curve flattens, the reasoning curve takes off. Which leads us to the actual, realistic goal the industry is racing toward by 2028, the fully autonomous AI researcher. We aren't building a single, godlike supercomputer here. We're building systems that can come up with a hypothesis, design and run the experiment, analyze the data, and start over, entirely on their own. And early versions exist today. Systems like Sakana AI are writing scientific papers from scratch, and Cosmos generated an estimated 6 months of human-level research in just 12 hours. It's iterative, practical, real science. Anthropic CEO Dario Amodei recently stated that we might be, quote, only 1 or 2 years away from a point where the current generation of AI will autonomously build the next one. So even with the limits of physics and economics holding back an infinite explosion, the feedback loops are undeniably getting shorter, and the ceilings of what these models can achieve are getting higher every single day. So if you're wondering what it actually looks like if AI takes over the world of coding and research, well, it isn't a sci-fi dystopia. Instead, it's something called the AI hive mind. Imagine not just one AI, but thousands of autonomous AI researchers running simultaneously, 24/7. They share data instantly, they build on top of each other's failures and successes, and they collaborate endlessly. This is the real intelligence explosion. It's quieter, it's highly structural, and it represents a massive overlapping web of automated research tightening the loop of innovation. Now, what's really interesting about this slide is the profound trend hidden right in the data. The human contribution to the actual heavy lifting of AI development used to be near 100%. Recently, it shrank to 95%. Now it's around 90%, and it is continuing to fall. Our role is fundamentally evolving. We're shifting from being the hands-on creators who write every single line of code to the supervisors who define the goals, set the guardrails, and manage this hive mind of AI researchers. Which leaves us with the ultimate question for you to ponder today. As this AI hive mind steps in to take over the heavy lifting of scientific research and coding, what is going to be your role in a world where the tools build themselves? How will you pivot from being a creator of outputs to a director of intelligence? I highly encourage you to think about how you can leverage these systems in your own field. Thank you so much for joining me for this explainer. Keep learning, and I'll see you next time.